Good morning, students. Good morning. Okay. So, there is some change. Actually, I had told that we will have periodic classification. We will start with the periodic classification of elements, right? But what we will do is we will solve some of these competitive exam questions related to first chapter. Today we are going to solve some of the questions which was or which has been asked in previous years with respect to some of the competitive exams, like that can be NEET, CET or IIT, whatever it is. Fine. So we will have selected some of the questions and we will start solving those questions. Fine. So whether I am clear? So today we are not going to start with the periodic classification of elements. Fine. So all of you have read and come first chapter. Basic concepts of chemistry. Okay. So basic concepts of chemistry. Okay, fine. So hagadre, can in that way, if you have read and come, can you tell me one by one which are those concepts which are present here? Or I will tell with respect to the questions which I can see in the previous year's old questions. I can tell that you can expect the question from significant figures. You can expect the question from significant figures. With respect to old questions or competitive exam questions, I am talking about. Okay. So you can expect the question from significant figures. And all of us we know zeros which are present between the two numbers. Okay. So that will be considered as significant figures, or all the numbers other than the zero will be considered as significant figures, but zeros which will be preceding the number, it will be not be considered as significant figure. All of you have understood? But with a decimal point after the number, if zeros are there with a decimal point, they will have the significant figure. They will be considered for significant figures. Okay. So that's where we have one of the concept you can expect from the competitive exam point of view. Then next one, the question can be related to, a question can be related to mole concept. A question can be related to mole concept. That means it can be molarity, molar mass. Okay. So not definition I am talking about. I am talking about the problems. So related to moles, we can expect the problems. Okay, that's what I can see. Zeros after decimal are significant. Yes, with decimal, yes, they are significant. Fine. So that's where another concept you can expect question from this part. Then we can expect the question from stoichiometric equation part. Stoichiometric equation part. You can expect the question from stoichiometric equation part. Okay. Now, when I am talking about stoichiometric equation, what do you mean by stoichiometric equation? It is related to a balanced chemical equation. Stoichiometric equations are nothing but a balanced chemical equation, right? So in that way we have the limiting reagent concept also, which comes under here. limiting reagent. Even this concept will be comes under stoichiometric equations only. So when it comes to questions, it will be related to these two parts. Maximum time they have asked the questions from these two parts, that is molarity, molar mass, then with respect to stoichiometric equation, that can be with respect to limiting reagent. Okay, so what I mean to tell here is, by using this concept you can solve those problems, those type of problem many times they have asked. And the last one is with respect to molecular formula and empirical formula. Okay, so from this part also they have asked, but still with respect to the molar mass, molarity, stoichiometric equation, they have asked many questions. All of you have understood? Fine. So that's where we can see the important concepts with respect to the competitive exams. Fine. So with respect to centimeter, meter, SI units, they have not asked. I think that will come in your physics topics. Okay. But in chemistry they have not asked. So it will be basically related to this concept. You can expect the question. So what do you mean by molecular formula? So this is related to representation of a molecule, where we can exactly tell what is the ratio of the number of elements. But when it comes to empirical formula, it just talks about the ratio. It just talks about the ratio of the element. Now, when it comes to molarity, even that one is there, right? But that will have more weightage in second period, because in solution topic we have second chapter in first part of your second PUC chemistry textbook. So where we have one topic called as solution. So in that topic you are going to have the more weightage, molarity and all. Yes, normality in your textbook it is not there, but competitive exam they have asked related to normality. We will discuss on that. Okay. So we will discuss on that. That is comes under mole concept only. That comes under mole concept only. Okay, normality. Yes, they have asked. Fine, but it's not there in your textbook. So that's what some of the few additional points you should know when it comes to competitive exams. Fine. Okay. So shall we start solving some of the questions? So what I will do is, I will write it on the board. Even you can write it down. You can maintain one separate notebook. And related to this, you will be getting homework assignments also. Okay? So therefore, before understanding, without understanding, don't go for next question. If you are not understanding, let me know. Fine? No need to hesitate. So the first one. How many significant figures? How many significant figures? How many significant figures are present in 0.000135? How many significants are present in the 0.000135? Okay, so please remember, it's not compulsory. I have not only taken from CET, NEET and JE. So some other competitive exams also have included the questions. Fine. Yes, all of you are right. Actually the option was 7, 8, then we have 4, then we have 3. And as people have, all of you have written, so the answer should be D, that is 3. So why answer should be 3? That is because, as we have discussed, zeros before the numbers, so they will not have the significance. That's why we have only 3 significant figures. Okay? So, sir, you might be having a question, sir. Zeros are after the decimal point, but still there are no numbers before the decimal point. So, therefore, zeros will not have the, or they will not contribute for the significant figures. It will be 3. Answer should be 3. Very good. Okay. So, next one, similar type of question. The number of significant figures, the number of significant figures in 10.3106 gram is, okay, and the option is 2, 3, 1 and D 6. Okay, so you should tell me the answer. Yes, some of you have written. Okay, all of you will agree with that. Vineet and Likita, they had written. Oh, okay. So we are in democratic country, right? So we have to go with majority. Yes. So answer is D. Answer is D because 1, 2, 3, 4, 5, 6. All of them, they are significant figures. Since zeros are present between the numbers, even zeros will become a significant figures. Okay? So all of you have understood? Any doubts in this? Anyway, these things we have solved even for the board examination preparation. And this one is important for your board exam. For 1 mark question you can expect related to significant figures. Okay? So we will move to the next one. 20 ml of methane is completely 20 ml of methane is completely burnt using 50 ml of oxygen gas. 50 ml of oxygen gas. Okay? The volume of gas left after cooling to room temperature is okay. So now this was I think from CT question. Option 1 is 80 ml, option B 40 ml, option C 60 ml, option D 30 ml. So 80 ml, 40 ml, 60 ml, 30 ml. So what is that question? 20 ml of methane is completely burnt using 50 ml of oxygen gas or oxygen. The volume of gas left after cooling to room temperature is. That's where the question. No Chidwan. I will not go with majority if they are wrong. Okay? Okay. So Shubhangi and rest of you have written okay 30. Oh, so many times. Okay, you people have written 30 ml. Any other answer? Even Dikshit. I am right? Dikshit also has written 30 ml many times, that also. Right? We will see whether it is 30 ml. Okay? So, Nirupit. He has written 40. Okay. Now, first thing, what we have to do? First thing, we have to write the balanced equation. First thing, we have to write the balanced equation. It's not compulsory, but to know the answer, we have to write oxygen, then CO2 plus water. Okay. So anyway, we have to balance the equation. So oxygen is 2, here it is 3, and hydrogen here it is 4. So I will make it as 2H2O. So here it is 2O2. That shows that 1 mole of methane is going to react with the 2 mole of oxygen. 1 mole of methane is going to react with the 2 moles of oxygen to give rise to 1 mole of carbon dioxide and 2 moles of water. 1 mole of carbon dioxide and 2 moles of water. Anyway, we are not interested in carbon dioxide and water. We are interested in reactants. So we have to focus on reactants. And they have given in terms of volume. So 50 ml, 20 ml. They have expressed the concentration with respect to volume. So we have to convert this particular mole into volume. How to do? We have to convert that one into volume. So what we will do is, we will consider this one as 22,400 ml, since it is 1 mole it is there. 22,400 ml, right? Now, CO2 to the 4, yeah. So here also it is 22,400 ml into 2, because 2 moles are there. That's where we have the methane, oxygen, which are in terms of 1 mole and 2 moles. So therefore it will become 22,400 ml, and it will become 22,400 ml into 2. So that will be 44,800 ml. Okay. So that is the volume. That is the volume we have got according to equation. That is the volume we have got, right? Now what we have to do next? So why we have written ml? Why not in liters? Because the question they have asked 20 and 50 ml. So that's why even these things we have written in ml. Okay. Now according to that, for 22,400 ml of methane, for 22,400 ml of methane, how much oxygen it requires? 44,800 ml of oxygen. According to this equation, 22,400 ml of methane demands 44,800 ml of oxygen. All of you will agree? All of you will agree. Now we came to know what we have to do. So naturally, for 20 ml of methane, how much oxygen is required? That's what we have to see. So therefore, for 22,400 ml of methane, how much oxygen is required? 44,800 ml of oxygen is required. How much for 20 ml of 20 ml of methane? It should be methane. Okay. So now ml of methane will get cancelled. Okay. Now 0 will get cancelled. Now naturally it will be 2 because it is double now. So it will be around how much it will be? 40 ml of oxygen. We require 40 ml of oxygen. Okay. So we require 40 ml of oxygen. All of you have understood? Now how much oxygen they have given? They have given is 50 ml. They have given 50 ml of oxygen gas. Given is 50 ml of oxygen gas. In that, how much will get consumed? 40. So it will be 50 minus 40 is equal to 10 ml of oxygen. Oh, okay. Option only it is not there. Okay. So whether I have written properly? So 80, 40, 60, 30. Okay. So option only it is not there. So actually answer is 10 ml. Answer should be 10 ml. Okay. All of you have understood? Since they have asked about leftover oxygen, leftover gas, we have to talk about reactants, not with respect to the product. So therefore, leftover, left after cooling to room temperature should be 10. But anyway, option is not there. Even I have written 80, 40, 60, 30 ml only. So anyway, this should be the answer. All of you have got? But some of you had written 30 ml. Okay, some of you have written it as, that's what Rohan. So 10 ml is not there, but 10 ml is the answer. I told sir, Nirup Gowda. Okay. But some of you have written 30, 60. Okay, fine. So once again I will repeat. So 1 mole of methane, 2 moles of oxygen. That's why we have to write the balanced equation first. Okay. So according to that, 1 mole of methane reacts with 2 moles of oxygen. Can you see? That's how it can be balanced. This is the balanced equation. Now in that case, 22,400 ml. So molar volume concept I am talking about. 1 mole of any gas will occupy a particular volume. So what is that volume? 22.4 liters. So based on that, I have converted that one into ml because these are in ml. So 22,400 ml and here it is 2 moles. Therefore 22,400 ml into 2. So it will become 44,800 ml. So next step is I have to find out what is the amount of oxygen which will be utilized. So in that way, for 22,400 ml of methane, how much oxygen we require? 44,800 ml of oxygen. So how much for given volume of methane? How much it will be required? So that's where 40 ml of oxygen will be utilized. That shows that 40 ml of oxygen will be burnt. So leftover I have to calculate because 50 ml it is given. So 50 minus 40 it is 10 ml because volume supplied is 50 but utilized one is 40. So therefore leftover gas will be 10 ml and that will be oxygen because methane is the limiting reagent in this case. Methane is acting as a limiting reagent. All of you have understood? So therefore leftover will be oxygen gas. All of you have understood? But I don't know, option it is not there. But anyway, 10 ml should be the answer. Even I didn't see. I just calculated and I came. Okay, fine. Yes, 1 mole will occupy around to 22.7 liter or 22.4 liters. Approximate that volume. 22.4 liters. Okay. So if it is 25 degree and all, then we have to increase the volume. So now it will become 24.7 or something. 24.7 or something. If temperature is increased. Okay, it will be at 0 degree. Yes, it will be at 0 degree. Oh, okay, even that one we can do. Yes. Since it is for room temperature they have asked, so what we will do is we will take it as 24.7. We will see whether we will get the answer. Yes, Rohan, we will try that one. Okay. Since it is asked for room temperature, we will consider room temperature as 25 degrees Celsius. So in that case it will become 24.7. Okay, so that means 24,700 ml of 1 minute methane. So how much it will be utilizing? 24,700 means into 2. For oxygen I am calculating. So 49,400. So 49,400 ml of oxygen will be utilized. How much for 20 ml of methane? Can you find the answer for this? Can you calculate? So I think it will be same. Yeah, it will be same. It has to be same. Okay, still you will be getting 40 only. Okay, answer will be same, 10 ml only. Whatever volume you take, you will get the answer as 10 ml only. That's for sure. Okay. So why I have calculated with 24.7? Because room temperature they have asked, right? So by considering that. So it will be 40 only, not 30. Okay, it cannot be 30, it will be 40 only. All of you will agree with me? Because same thing we are going to get. Same thing. So 24,700, it is double is 49,400. So it will once again 2 to the 4 only it will be. Yes, it will be same answer, 10 only. Fine? So anyway, option only it is not there. I will cross check whether I have written the wrong options or the question was like that only. Sometimes it will happen. Even I didn't check the option whether it was there or not. Okay. All of you have understood? Okay, so it will be same, no doubt, it will be same. Okay, so we will move to next one. The mass of oxygen gas. Next question, the mass of oxygen gas which occupies 5.6 liters at standard temperature and pressure would be okay, at standard temperature and pressure would be A, the gram atomic mass of oxygen. The gram atomic mass of oxygen. Option B, 1/4 of the gram atomic mass of oxygen. Gram atomic mass of oxygen. Next, double the gram atomic mass of oxygen. Double the gram atomic mass of oxygen. And the next one, half of the gram atomic mass of oxygen. All of you have understood? This is what the option. The mass of oxygen gas which occupies 5.6 liter at STP. STP means standard temperature and pressure would be. So which are those options? Option A, the gram atomic mass of oxygen. Option B, 1/4 of the gram atomic mass of oxygen. Option C, double the gram atomic mass of oxygen. And option D, half of the gram atomic mass of oxygen. Can you write? Can you try it out? Sir, in the previous question by asked us about the Leftover gas, no sir. So we should have considered CO2 also. But if you consider CO2, leftover gas, it looks like it is with respect to reactant. It will be with respect to reactant. Okay, leftover means it looks like it is related to reactant. Okay, I will try that one also. We will first solve this one. Okay, we will try that one once again. Previous one once again we will try to solve it off. So first you can have a look on this. So some of you have written option D, right? ml. 20 ml it is there? No. I think we cannot consider carbon dioxide because leftover oxygen. It is amount of product produced. Leftover word will not come. Okay, anyway, we will try it out. Okay, but this one, option D, all of you will go with option D. Pavitra, we will come to that. First we will solve this one. The mass of oxygen gas which occupies 5.6 liters at STP would be. What will be the answer? We will come back to previous one, don't worry. So what will be the answer for this? Option B. For the fourth one. This is fourth question. Shashank is still with that only. Okay. So we will consider carbon dioxide. First solve this one. (5.6 into 4, 22.4 liters. So I want the option. Okay. So according to this, okay, they have asked about mass of oxygen, right? So oxygen means O2. So what is the mass, atomic mass of oxygen? Atomic mass of oxygen is, atomic mass of oxygen is atomic mass of oxygen is 32 gram, right? So 32 gram. So according to this, since they have asked about volume, so for 32 gram of oxygen it corresponds to how much volume? 22.4 liter. We will keep it in liters only. Okay, we will keep it in liters only because standard temperature and pressure they have asked. That means we have to consider 0 degree. Okay, so 22.4 liters. Fine. So then we have to calculate how much it will be for 5.6 liters. It's very simple. Okay. So for 22.4 liters of oxygen, 32 grams of oxygen will be there. How much for 5.6 liters of oxygen? That will give you the answer. Since STP they have asked, we have to consider 22.4 liters only. Okay? Yes, Rohan, it is 16 into 2. So that is 32 gram. So 32 gram corresponds to 22.4 liter. So in that case, here the answer will be, if I am right, 8 grams of oxygen. It will be 8 grams of oxygen. Okay, it will be 8 grams of oxygen. That is nothing but half. Yes, that is nothing but half. Half of 16. Right? Therefore, option D should be the correct answer because atomic mass, here it should be molar mass. Atomic mass of oxygen atom is 16 grams. So therefore 8 is half of 16. So therefore half of B, it will be half of the atomic mass of oxygen. This should be written as molar mass. So molar mass of oxygen is 32 gram. Why? Because 16 into 2, 2 oxygen atoms are there. So finally we have got the answer as 8 gram. So naturally atomic mass of oxygen atom is 16, 8 is half of 16. So therefore option D should be the once again answer. All of you have understood? Any doubt in this? Option D should be the answer. Okay. So it is also based on molar volume, molar mass. Okay, it is also based on molar volume. Try to focus on STP. Since they have a standard temperature and pressure, it should be 0 degree Celsius. Okay, fine. Okay, we will go back to previous one. Okay, fine. That is also fine. Since carbon dioxide is also gas. Okay. Okay, fine. We have to consider carbon dioxide. We will try it with that. Fine. Leftover of gas means it can be even product also. Okay, fine. We will include that. We will see what will be the answer. So I am going back to previous one. So that is CH4 plus oxygen, carbon dioxide plus water. Okay. So 2H2O, 2O2. So here we will take 24.7 because they have asked room temperature na 24.7 liter. So here it is 24.7 into 2 liter and once again 24.7 liter product. Fine. So with respect to oxygen we have already calculated. With respect to oxygen, leftover is 10 ml. All of you will agree? Leftover is 10 ml. Okay. Now we will calculate how much for carbon dioxide, how much it will be formed. Since limiting reagent is oxygen, how much they have given oxygen, how much it will be consumed. Using 20 ml of methane. Okay, methane is the limiting reagent, right? Oxygen is in excess. Okay, since methane for 24,700 ml of methane, it will give how much? 24,700 ml of carbon dioxide. So in that case, how much will be for 20 ml of methane? Given methane is 20 ml, right? So it will get cancelled. Ml of methane will get cancelled. So okay, fine, we are getting the answer. So therefore 20 ml of carbon dioxide will be there. Yes, we are getting the answer. So therefore leftover gases will be so 20 ml of carbon dioxide plus 10 ml of oxygen. So finally total it will be 30 ml of gases. Okay, option D will be the answer. Yes, some of you had written. It is 30 ml of gases which will be left over. We are getting the answer. Question was correct only, but I didn't added carbon dioxide. I should have added this one. Okay. So 30 ml. That is option D. All of you have understood? So oxygen we had already calculated. That was 10 ml. Now we have calculated for carbon dioxide because leftover gases means yes, even product will be there, right? So we have to include even product. 20 plus 30, 10. It will be 30 ml. Fine. All of you have understood? So option D, right? Option D should be the answer in previous case. Earlier question. Even for just now we have solved, that is for option D only. Yes. You people had told, but I didn't recognize that. Yes. So it was correct. So 30 ml should be the answer. You people are correct. Shall we move to the next one?